This is Professor Rudy, and this video is about file input and output in MATLAB. So I've already generated a script for this video that I'm just going to kind of work through. The first thing that I want to discuss is how to display things just directly into the command window. So this isn't talking about files yet, this is just how you can display things directly on the screen. So the first statement I'd like to talk about is the display statement. That's DISP for display. And the way this works in general is you can just type something in there like text. Like for example, this line here will just display this text here, this text string. Remember, strings are separated by single quotes, and it will display whatever is on that text on the screen. Now, the way you can use this to display different values or things that are stored in variables, so I have three example variables here, x, y, and z, and what we can do is we can display these values in those variables, but what we need to do is we need to take those values and convert them into a string, and there was a MATLAB command for that called num2string, num2str. And when we do that, what will happen is it'll take the number 5, but it'll make it a string 5. And then once we do that, we can put that into a display statement. And then we can also even put additional text around that. The extra thing we need to do then is we need to use square brackets to combine the strings together. So inside of square brackets, I have this string that says x equals, and then this string, which is going to be a string of the value 5. Now we can do this another way where we put the number first. So we start with our num2string of y and then add on this text on the end. Or we could even do that in the middle where we just have three strings. We have this string, z is, then followed by the string version of this value, and then this last part here. So I'm going to run this section of code. So this is what's displayed on the screen. So this display statement said write examples using DISP. So that's this here. Then we have x equals, and then the string 5. Then 4.2 is the value of y, and then z is this value, which is square root of 2. So that's how you can use the display statement, and you can use these square brackets and num2string in order to include values in there. This is a nice way to display results for a problem. So for example, if you have a script that calculates something and has an answer, this is a good way to put what that answer is. You could put units on the end and other ways to describe your answer instead of it just being a number. The second technique that we can use to display things to the screen is called fprintf, and this works similar to the display statement, except it handles the numbers a bit differently. One of the things with this statement is that you can just have fprintf and then you can put a string in here. One thing you'll notice in this string is there's this \n, and what that will do is that will give you a new line. It's basically like hitting the enter key in your display window. So what this will do is this will start it'll put in one blank line, then display this text, and then go to the next line. And if you don't put these \n's in here, you'll just keep printing things to the same line. So that's why you typically have one of these at the end of your fprintf statement. So this is just going to display text. This next line, what it's going to do is rather than have the string interrupted by this num2string and kind of squeezing it in the middle, what you do is you just type your whole string out and then you put in a placeholder for where you want your numbers to go. So in this case I say x equals. Now this is what we use as our placeholders for variables. We have the % and then followed by a certain letter. And the ones that are most commonly used are d, which is going to give you like an integer value. So that's what we're doing here. This next one, f, it stands for a floating point number, but those are basically your decimal values. And then we can also have %s, which will do an actual string, but it could be a string that was contained in a variable. So if we had this variable here, which has the string, remember, single quotes, string yes, it will plug that in this placeholder. when we put that value in. So this works as put in your string of text with your placeholders in here. Now you could have more than one, and then you just have more than one variables on the end here, but then it'll take these variables and plug them into those placeholders. So if I run this section of code, remember I get that blank line from that first \n, then I have my examples line, then all of this information. So what this did is it took the variable x and it displayed it as both an integer and a decimal. So if you know something is an integer value, typically you want to display it as such. I don't want to see 5.00000. It's also interesting if you try to display a decimal number as an integer, you get this, which is also kind of weird. So in general, you would have this statement for x and this one for y. You just need to know what type of number you expect. And then down here, this last line, the answer is yes. So this did the answer is, and then when it hit to this %s, it just plugged in whatever was in this variable. And so that's how you can use fprintf to display things to the screen. So now let's get into a little bit of file input and output. So for this next example, what I'm going to do is first I'm going to start by creating a vector of different cases of mass and different cases of acceleration. So then I'm going to use Newton's second law to calculate the force as mass times acceleration. But what I want to do is I want to do that for every different combination of these cases. So it's not just as simple as taking m times a, or m dot times a would do element by element, so we could get, you know, what it is with this first case and this first case, and then this second case and this second case. But that's not what I want. I want 0.1 mass evaluated at every acceleration. So one way we can do this is by using for loops. And what's different here is that now we want to use two for loops. And this is what's called a nested for loop. We have one for loop on the outside, and then we put another one on the inside. So what happens is I loop through this first one with an index I through the different cases of mass. And then for every case of mass, I come inside the loop, and then I loop again with doing the different cases of acceleration. So basically I say, for the first case of mass, I do every case of acceleration. For the second case of mass, I do every case of acceleration. And I continue going through there until I've done every combination. So inside these loops, then I calculate the force as just mass times acceleration, where here I want the mass at index I and the acceleration at index j. Then I'm storing these in a matrix, so this will be rows corresponding to mass and columns corresponding to acceleration, and then I can do this loop and it will calculate all of those for me. Now before the loop I have this statement here, which is just initializing that matrix to the size that I know it's going to be, so it's not changing size every time in my loop. If you were doing that, it would really slow down your program. So if I run this section of code, what I get is, and I know it's a little hard to see, but I have now an F matrix which is 50 by 11 because I considered 50 cases of mass and 11 cases of acceleration. So that's just a matrix. If I look at that, you know, I have a bunch of rows and columns of data here. So it's a matrix, or it's like a table of values. So that was just generating my data. Now for the next step, I want to take that data and I want to put it into a file. And so the first file I'm going to talk about is a text file. So basically the way a text file works is we start by just opening up the text file. So we use this statement here where FID, this stands for file identifier. This is just a variable. You can call this whatever you want, but you need to know this variable so that you're referring to the right file. This is MATLAB's way of assigning an index essentially to this file. So it'll open the file, give it an index so it knows where to find the information. So with that we use fopen, file open, give it the file name, and if you just have your file in the same folder, you just need this. You could also put the whole file extension in here if you wanted to put it in a different location. Then this last argument here is telling us what we're going to do with this file. So the W stands for write. as in we're going to write to the file, as opposed to R, which would be for reading the file. And the T is telling us that we're going to write it as a text file, as opposed to binary, which is another way of storing data that we don't really want to talk about. Now again, for this, what we can do is we can do that same idea of looping through the different cases of mass and different cases of acceleration, and then as we hit each point in that table, I'm going to write one number into the file. So this line right here is going to print the data. So notice we're using this fprintf statement again, but if we include a first argument here of the file identifier, it will then write this information into a file rather than into the command window. So if we put that FID in there, it's going to write into this file that we opened up. Then we want to tell it what we're putting in there. So this follows the same convention as we were using before. So we could put %f here, but I did want to point out that you can be more specific in the information that you provide. So in particular for these floating point numbers, if I wanted to have 2 decimal places, I do this 0.2f. Now what I have here, this 8, what that corresponds to is it's basically how many digits of space I'm going to give this. And by putting a value here, this will help keep things nice and evenly spaced as you write the data. So it'll basically give us 8 blocks to put this information into, and this part will give me 2 decimal places. And then as I go through, we will kind of keep this even spacing of 8 characters as we go across. Then the last part here, this is just the number that we want to put in here. So I don't have any text, so notice there's no text in here, but this is my placeholder, and this is what I'm going to put into it at each combination of I and J. So once we do that, in this J loop, this is going across a row. So we're going to write this value, then this value, then this value, then this value, and so on until we get to the end of the row. Then once we hit the end of the row, what we want to do is we're done with that loop. We do want to go in here and end the line. So we have just an fprintf statement in the file where we put in that end line character, that enter, so that we move to the next row. So then when we go back to our loop here, we come back, we'll be starting fresh with the next row as we hit these lines again. If you don't do this, you will just do this all in one big line. It will just keep printing data across one row. So you want to make sure you put this in here if you want to get a nice table of data. So if we run this section, then we could open this up. I just got to find my force table.txt, open that up, and this is what that file looks like. So MATLAB can open text files. You could also open this in Notepad or WordPad, but this is what the file looks like. So we've got going across the rows and then columns here. Notice, so this spacing right here, that was from that 8. We had the %8.2. This is the 8, so that we have this nice even spacing going across. If we made that 10, we'd just have an extra 2 spaces in here, and they'd be a little bit more spread out. And then the 0.2 is keeping this limited to 2 decimal places, as opposed to the kind of default 4 that MATLAB uses. And you could do more than 2, less than 2, but that's how you adjust that. So that's good. We wrote our table to a text file. Next, I want to talk about reading from a text file. So for this case, this might seem a little bit silly, but I'm going to read data back in from that text file that we just made. So we already did have that information, but pretending that we didn't, and we're starting a code and we just have this text file, we want to get that information, what we can do is we can use the import data command. So if we have a text file that's just like that file that has a table of values, it's just numbers, there's not any difficulties in there with text or headers or different types of numbers, we can just use this import data command and give it the file name, and it will give us text data here where this is going to be a matrix. And really that matrix is going to be the same thing as f. I just wanted to use a different variable to show you that this statement brings this into this new variable. It brings the data out of the file, not from earlier in the code. Then we could So wherever we got the information from, we can also save data to spreadsheet files. So Microsoft Excel files, the XLS or XLSX files. And we can do that using the XLS write command. So by using XLS write, we give it a file name. So this will be forcetable.xls. And then all we really need to do is give it the matrix of data that we want to put in there. It'll just default to starting that at the first cell in the spreadsheet, and it'll put the data in. There are also options in the XLS write, so if you're interested, you can do a help or doc SLS write and read more about those options where you can place things into particular sheets or particular cells or do other more complicated things. But this is the most basic idea of just putting that matrix of information into an Excel file. So let's run this section. All right, so that doesn't seem like it did anything, but it should have generated this file, which I have over here. I'll open that up. And oh, I don't want to open it in MATLAB though. Oops. I'm just going to open up that file in Excel. So opening up that file in Excel gives us this, where we have now this information that was in that table, except now rather than being in a text file, we have it in a spreadsheet file. So it depends on what you want to use these for or how you want your data stored, but you also have this option. So we wrote that data there. Now we have a new file, this .xls. So in this next section, what I'm going to do is, again, I'm going to pretend that all I have is that file. I didn't already do this stuff in this script. And then if I wanted to load in data from the Excel sheet, I can use XLS read. So given that Excel file that we just looked at, I can read that in. We can get 3 different information pieces out of an Excel file. So as you know, if you've used Microsoft Excel, you can have text, you can have numbers, you can have all sorts of different things in the different cells. So what this statement will do is this will find the numbers, it will find the text, and then it'll just take the raw, which is basically everything, and it'll give you each of these pieces of information. So for our case, we only really have numbers, so num is the only part that we care about, so that's what we'll use. So when we run this, we'll get a matrix num that is the same as text data, which was the same as f. They're all the same thing. I'm just using different variables to show you where these are coming from. So once we use this statement, we get that. Then this last part is just showing an alternative way to display a matrix of data. So we had the different values of mass, the different values of acceleration, and then this matrix of values. So this last one was num, but we could also have used text data or f, and those were those force values. And so we can use the surf command, which is short for surface, which is going to plot a 3-dimensional surface of that information with basically the matrix is what is being plotted, so that's going to be on like the z-axis, but then we can also give it the x and y axes and what they correspond to. We can label these with our units, so we use x label, y label, and, surprise, surprise, the z-axis we can label with z label. And so now let's run this section of code. So we read in that data, and now we've created this figure. So we see that this is looking at variations in acceleration, this is looking at variations in mass, and then essentially the height of this surface here, which is also represented by color. So the more red this color is, the more force that we have. Just one thing I didn't include before, but I'll just do it in the command window. If we type color bar, we can even see, whoops. There we go. We can even put this color bar up here that will give us what the colors correspond to. So not only do we have the z-axis here, we could also use this color scale to tell us that the reddest point is 5 and the bluest point here is 0. There's also different color scalings you can use. That's the color map command, so you can look into that if you're interested. But this is just another way this is looking at that table of data in a visual means. So we basically have the points in that table plotted and connected together in this nice color-coded surface. So that's how you use the surf command, and that's a kind of general overview of file input and output. There are multiple ways to read and write information. These are just a few of the examples of how to do that. Some of the other commands you might want to consider are fscanf is kind of the parallel to fprintf, where you can read in particular pieces of information. Like maybe you have a row of data where there's 2 integers and then 2 decimal numbers and then a string, and you could use that %f, %d, %s to pick out those particular values. So that's another one you might want to look into, but this is kind of the basics of file input output. Thank you.